30 seconds. 20 seconds. 10 seconds.
Hi,
My name's J.C. McCauley.
I'm Naisha McCauley, and
Well,
you're watching AccessTV.org.
Good morning again. This is Jonathan Small, host and producer of Face to Face. And Face to Face is one of two different programs that I have the pleasure of hosting and producing live every single week at AccessTV.org studio. Face to Face is a show that's designed to ask the guests the hard questions and give you, the viewers, the answers and information that you deserve to know. This morning on Face to Face, I have one of the top aviation analysts in the United States. He has a tremendous background as not only a commercial airline pilot, also corporate general aviation airline pilot. He does media coverage as an aviation analyst for NBC News and other media outlets related towards, I believe, Peacock or Comcast. The guest this morning on Face to Face is no other than Safety Operation Systems. He's the president and CEO of Safety Operation Systems LLC, based in Florida. No other than John Cox, Captain John Cox at that. Good morning, John. How are you doing?
Good morning. Very well. I hope you are also.
Doing fine, Captain Fox. John, could you let people know a little bit about yourself and background briefly before we get into our main topics of discussion?
Sure. I've been in aviation a long time. It's 54 years this month. I've worked as a corporate pilot. I did 25 years as an airline pilot. I was an instructor there. Also did some test work there. I've been an accident investigator for 35 or so years. And in the last 20 years, I've been a full-time safety analyst for a number of companies around the world. So it's a pretty wide, varied background. I've had the privilege of really having a really unusual and a lot of fun career.
John, I believe in the United States and throughout the world, aviation is the safest form of traveling that exists for a very long period of time. But of recently, over the past couple of years, in particular, we've heard incidents with Boeing, in particular, some of the safety issues that particular company has been dealing with, particularly I believe it's the 737 MAX jet plane. And at one point, Boeing had to ground, I believe, that particular plane, the 737. Could you kind of give people a little bit of an update on some of the issues that is relevant towards passenger safety, in your opinion, with the Boeing 737 aircraft?
Sure. One of the things we have to recognize, and you hit it right on the point, that aviation today is the safest form of transportation ever designed by humankind. If you look in 2023, we moved about 35 million passengers. I'm sorry, 35 million flights, commercial airline jet flights, without a single fatality or even a single accident. It's a remarkable journey from our first flight in 1903. So, how have we gotten there and can we continue to improve? That's really the focus of aviation safety today. We have had some incidents, but one thing to recognize is because of the rarity of those incidents, they get a lot of media attention. As an example, the 737 MAX door plug on the Alaska flight that came off, the airplane landed safely.
Hmm.
It got a lot of media attention, as it should. And there was a lot of investigation, a lot of inquiry, as there should be. But that level of investigation and that level of inquiry and the push to try to make aviation constantly better is how we've attained this incredible record that we have. We fly the population of the planet about every 25 months. It's remarkable. And so I get asked a lot about how safe is flying. And the question, the comment that I make, and it sounds a bit flippant, but it's actually the truth. The most dangerous part of any flight is the drive to and from the airport.
I thought you was going to say the takeoff and landing. You kind of answered to something that I was not quite thinking of, but I used to always hear a family member used to always tell me the most dangerous part of flying would be taking off or landing, or the most challenging part. But you said that's not even the case in this particular
It,
matter. Okay.
Once you get on the airliner, you're in a remarkably safe environment.
Yes.
Um, we I talk with a lot of people that are fearful flyers, and they're generally not persuaded by the facts, the statistics that talk about how safe it is. They will easily go get in a car, and they're sitting in a 3,500, 4,000 pound vehicle passing within a few feet of another 3,500 or 4,000 pound vehicle, literally just a very few feet away, and think nothing about it. So if you look at aviation and you say, okay, what are the most the areas where we have the higher risks in the flight profile, takeoff and landing, because you're close to the ground,
Hmm.
they naturally come up. But even so, it's been very interesting over the 54 years that I've been a pilot to watch how much better we've gotten. And I'll give you this. I learned to fly in 1970.
Hmm.
And if we had the same accident rate today that we had in 1970, and we thought we were doing pretty well, there would be something over 65,000 additional fatalities that would have occurred had we just maintained that same rate.
Hmm.
But they didn't. They didn't, and it was because we've gotten better.
Okay, Captain Fox, that is a great breakdown or like an introduction towards aviation safety. You mentioned something earlier about the door incident on the Boeing 737. And I think the one thing that might alarm people, first of all, you shouldn't expect that to happen on a particular aircraft. But wouldn't it be the case if passengers weren't wearing their seat belts, they would have been sucked out of the airplane? Or would have been a way to, let's say, prevent that if that was the case?
A couple of things that you have to recognize with that particular Alaska Airlines event. One, they were still at relatively low altitude.
Hmm.
The door departed, they were about 16,000 feet. As a result, the pressure inside the airplane was not a lot greater than outside. So there would not have been this push that you would have felt if there were a catastrophic decompression at, say, 35 or 40,000 feet,
Hmm.
because of the differential pressure between outside and inside. So I do want to make the point that the single largest thing, the single most important thing passengers can do to ensure their safety and the safety of others is, when you're in your seat, have your seatbelt fastened. I do it. Every aviation safety professional that I know, if you're in your seat, whether you're sleeping, whether anything, if when you're in your seat, that seatbelt is loosely fastened, it will prevent the likelihood of uh, injury during turbulence. It will prevent the likelihood of you causing injury to someone else in turbulence or at any other time through the flight. So I really can't overemphasize how important wearing that seat belt is to your personal safety and to those around you.
You think we're getting closer to, let's say, the FAA mandating that all passengers have to wear the seatbelt throughout the entire duration of your flight, maybe with the exception of going to the bathroom?
Um, I think what they're going to say is that if the seatbelt sign is on, because people want to get up and move around, particularly on longer flights. I was on a 16-hour flight recently, and you want to get up and move just so that the blood doesn't pool in your legs and so forth. So I understand that. I think the point being is if the seatbelt sign is illuminated, you need to have your seatbelt on, period. And as a matter of habit, that if you're in your seat, you need to have your seatbelt at least loosely fastened.
Now, when you hear incidents of, let's say, turbulence, I guess turbulence flights, it's always something that people in the past would assume it deals with the weather pattern, something that you could kind of predict or monitor. But you have a so-called clear turbulence. Could you kind of identify the differences between a clear turbulence and the other forms of turbulence that exist in the air sky, and I guess in the air pattern and the airwaves that we have flying towards?
Sure. Clear air turbulence is one that you're not in clouds, you're not near thunderstorms or anything like that. You're in clear air. And what's happening is there are very high velocity paths that air will flow sometimes. They're known as jet streams. And they can have winds in excess of 200 miles an hour in those jet streams. And just outside of the core of the jet stream can be wind of much lesser velocity. And so, just like water, when you have fast moving water and slow moving water, you will see these eddy currents or areas of turbulence, these whirlpools that will form. Air is pretty much the same way. The issue is that if the flight flies into those, it can be quite significant in the amount of turbulence that they experience because over a very short distance, the wind direction and velocity is changing dramatically. So that the challenge up till now has been the fact that we can't predict with any certainty where that clear turbulence is. Fortunately, in the recent couple of few years, the analysis of weather patterns and also the predictive ability to say where there is a likelihood of clear air turbulence has improved. And so airlines and pilots are able to route their flight around those potential areas of clear air turbulence. But unlike a thunderstorm, unlike turbulence that you might get in a rain shower, the aircraft can't see it. Weather radar really bounces an energy pulse off of the water in a thunderstorm. And so you can actually see the velocity of the raindrops moving, and it gives you some idea about the potential turbulence. In clear air, there is nothing for them to bounce that energy pulse off of. There's emerging technology using light called LIDAR, and there's testing and research going on. So I'm hopeful in the next few years that we will have a much better and more accurate prediction capability for clear air turbulence. But that oftentimes is what you read about in the media when they'll say there were injuries at a flight. It was because they unexpectedly ran into clear air turbulence and people didn't have their seatbelt on.
Well, Captain Fox, isn't there different weather patterns throughout the world as a former pilot that has more turbulence issues than, let's say, another area of the world? Like they would say if you fly through, let's say, the Caribbean, you may be more subjected to more or less turbulence. Has that always been the case, or has there been some new evidence just for certain parts of the weather conditions that exist and climate changes, that some parts of the world are going to always have more issues with turbulence comparable to other parts?
Absolutely. There, if you get around mountains such as the Himalayas, the Rocky Mountains, the Andes, um, there is a much stronger likelihood of encountering a turbulence event there than there would be over the Midwest or Central Africa or places like that. Um, there are areas around the equator. The technical name is the Intertropical Convergence Zone, where you have air moving in different directions. There's a lot of moisture there. Thunderstorms tend to breed there. You can get turbulence there, and that's well known. And so, if you get into the monsoons in certain parts of Asia, you can have turbulence there. So,
Okay.
there's
Okay.
seasonal changes that cause an increase in the likelihood of turbulence. There are geographical areas that cause changes in the likelihood of turbulence. And then there are weather patterns when you have things like deep low pressure systems that cause blizzards or hurricanes, um, or typhoons. There's turbulence that can be associated with them. So there's a lot of factors that pilots and dispatchers weigh in, and when choosing the route around an air for a flight, to try to minimize the likelihood of turbulence. But climate change is playing a part of it as well. We're seeing more turbulence as our global climate warms. So that's just a fact. So we're having to get technology to do better predictions so that we don't have unexpected turbulence encounters.
Well, Captain Cox, isn't there certain elements, let's just say, what conditions can an aircraft fly through and are not allowed to fly through? Like, can an aircraft fly through rain, heavy rain, snow, sleet? What are some of the conditions of, let's say, a particular aircraft? What the FAA allows them to fly through and what they don't allow them to fly through?
It it's up to the pilot. It's up to the piloting command, the captain, um, as the final authority. Now, we don't fly in thunderstorms.
Hmm.
Period. And we have weather radar on board to find those thunderstorms and to stay around them. And there's much better ground radar, Doppler weather radar that shows where thunderstorms are. So we do not fly there. There are visibility requirements that you must have so that landing in reduced visibility in fog, depending on the equipment at the airport and depending on the equipment at the airplane, on how low the visibility can be and you still safely land. We fly in rain. I've been in very heavy rain at times. The airplanes are designed for that. The engines are designed for that. Snow, none of us like to fly in blizzards. And at the worst of the blizzards, when you have such high winds, you may cancel flights because the runways themselves are quite slick. And if the wind rather is not pointed right down the runway, that is going to cause you potentially to slide on a runway. And so they oftentimes during the core of a blizzard, they'll close the airport. So there are a lot of conditions. There are maximum crosswinds that you can have, and the newer airplanes, they're displaying the actual wind on that is affecting the airplane's flight path in real time. You literally have instantaneous wind readout, so you know what the crosswind components are, and so that lets you, as a captain, make the decision of are we going to exceed the limitations or not, and then if you have a chance or a likelihood that you're going to exceed those limitations, then you don't land on the runway, you go somewhere else.
Okay, Captain Cox, this may not be a fair question, but it's kind of like I say, brings back to the two most pressing issues you've been hearing about over the past couple of years in aviation: the Boeing 737 aircraft, the Boeing 737 MAX, I believe, and let's say a lot of issues with turbulence. As a passenger, and if you can kind of separate yourself between a captain and a passenger, right now, what would be the most concerning issue to you? The turbulence issues with some aircraft like Southwest Airlines flying too low to the ground over the past couple of months, or just some of the issues related towards Boeing, towards certain aircrafts, how it's being handled, how bolts and other parts that puts together that particular aircraft has caused some criticism towards. If this is a fair or unfair question, what, in your opinion, would be the most concerning of the two as a captain?
Um, in both cases, I think the question I get asked is, are Boeing airplanes safe? Unequivocally, the answer is yes.
Mm-hmm.
Um, so I mean, I get on a Boeing airplane. I don't really think that much about it. Boeing over the years, and I flew the 737 for 15 years. I've got about 8,000 hours flying that airplane. Um, the the quality of the Boeing product has historically has been extraordinarily good. The Max issues brought to light that the quality of the manufacturing processes at Boeing had degraded, and that it's very sad to me. And that, in that respect, I'm disappointed in Boeing. I think that they are and have recognized the errors made in the past, and they're taking steps to improve it. But the loss of the two 737 Maxes and the grounding of that airplane for about 20 months, uh, the financial impact was huge, but an even greater impact was the reputational damage that Boeing suffered because they should have known better and they made decisions to expedite the airplane's entry into service. Those were conscious decisions and they were bad decisions. Now, the 787 has had some issues, but I've been on 787s. I mean, I've been on 737 Maxes. I believe the airplanes are safe, and I think that the data supports that. When you look at the incident and accident rate for those aircraft, they're still very, very, very low. They're not good enough because of our expectation of safety for any kind of commercial airliner. Anytime that we get on an airliner, we expect to arrive at our destination safely. And so anytime there's even a one-off event, that causes significant concern in the traveling public, as it should. Now, if you go back and you look at the the door plug incident with Alaska, that was caused because some bolts were not installed. The underneath question, or the really fundamental question, is why wasn't the paperwork showing that those bolts were removed initiated? Where did the people there think it was okay not to follow process and procedure? That's really a bigger question. And that's the one that the questions that FAA and the National Transportation Safety Board and all of us in the industry, particularly those of us in aviation safety, those are the questions that we're really posing at Boeing. Where was the process breakdown? They're highly skilled people. I mean, I've been on the 737 assembly line in Renton, Washington, several times. They're highly skilled people that put these airplanes together. Where did the process fail? So I think that when you say what is of greater concern, uh, right now I would say the process failures. And when you look at the incidents that Southwest has had, those have process implications as well. So you have to look at it from that perspective. And I think that the Boeing issues, they've just gotten a brand new CEO literally last week. And that gentleman who came from Rockwell Collins has a very distinguished reputation. And can he lead Boeing back to the engineering excellence of times past remains to be seen. I certainly hope that he can. So I think that you're seeing aviation right now, notably Boeing, um, having to make some pretty heavy adjustments going forward. I mean, there will be a successor to the 737. What's it going to look like? How long is it going to take to certify? What are the FAA's criteria for that airplane going to be? All of those are emerging questions. And so I look forward to the next generation of airplanes, both by Boeing, by Airbus, by Embraer. Those are our three primary airliner manufacturers. I think that the next generation will be amazing to watch. And I expect that their incident and accident rate will continue to improve um, as every generation has since the dawn of aviation.
Well, John, let's just backtrack one more time towards the Boeing 737 issue. Wasn't there two airline crashes of an Ethiopian airline and another country airline? I think it was 2018, 2019, by a Boeing 737 aircraft that crashed and lost lives. And wasn't Boeing found responsible? I don't know again how the National Transportation Safety Board ruled those two crashes, but do you remember or do you have enough evidence to say that Boeing had some legal charges against them related towards those two crashes?
Absolutely. There
Hmm.
was a Lion Air crash in Jakarta, and there was an Ethiopian Airlines crash in Addis Ababa. Uh, there were a number of issues, and Boeing clearly had liability for part of those issues. I testified in front of Congress in December of 2019, and I was asked about those two accidents. And as a experienced accident investigator, I told the Senate committee there that these are some of the most complex accidents I have ever seen because they have design issues, they have certification issues, they had operational issues, they had oversight issues. All of these came together to cause the tragic loss of those 346 lives. That said, the airplane was grounded and significant changes were made to some of the design parameters of the 737 that should have been made before the airplane entered service. Clearly, what they call the MCAS system, not having redundancy. When I very first heard about that, I was shocked. How could they not have a redundant system for a system that's capable of challenging the pilot for control of the pitch of the airplane, the up and down motion? Uh, that was a total breakdown on Boeing's part, but the FAA certified it. So the FAA also has a piece of this uh, that says we should have demanded that Boeing change that design. So it, like so many things, it's not simple. But to your question, did Boeing have legal liability? Absolutely yes. And the Department of Justice has has charged them and required significant changes to prevent further criminal prosecution. And then after the Alaska door plug incident, they revised and initiated charges against Boeing. And I think within the last month or so, they have come to agreement about what Boeing is going to do going forward. At, in an effort, they're paying fines, and the families of the victims, understandably, want even more. But the Department of Justice has been very much involved with Boeing and the loss of those two airplanes.
Captain Cox, does Boeing actually make the entire airplane? Because you may have certain companies that they might just build and design, let's say the engine, but is Boeing actually responsible for building an entire aircraft, or is it just certain pieces of the airplane that Boeing is responsible for building, like the 737 MAX?
The Boeing has a large number of sub vendors. I mean, the engines are produced by a consortium between General Electric and Safran, a French company. Um, the original fuselage is built by a company called Spirit Aero Systems in Wichita, Kansas. They're built to Boeing specifications, and Boeing, as the what they call the OEM, the original equipment manufacturer, has the overall responsibility no matter who assembles it. So you can have components that come from Japan, that come from Ireland, that come from France, that come from the UK, and they're all brought together for the 737 at the assembly line in Renton, Washington. But Boeing overall is responsible for the actions of not only their employees, but also their sub vendors. So the accountability rests with Boeing. Now, that said, the uh, the case that Spirit Aero Systems in Wichita assembles the fuselage. Spirit has a requirement, an obligation to not only meet the Boeing specifications, but to also have a safety management system in place to ensure conformity with those specifications. So they have, in essence, they have to they have to prove to Boeing that they're assembling the airplane properly, and then they ship the parts to Boeing, and then Boeing does the final assembly.
Um, John, I just want to go back a little bit because you've heard so many stories. Like you say, aviation safety has been in the United States in particular, but like even throughout the world, the safest form of flying. A couple incidents that draws to mind. Let's say the TWA incident that took off from JFK International Airport. I believe that was in 1996. What was the cause of that crash, if you remember exactly? I thought it was some type of mechanical issue, but just wanted to clarify that issue
That
with you.
The flight you're talking about is TWA Flight 800,
Right.
and it's one of the most extensive investigations in NTSB history. Uh, I know the investigators personally. I've talked to them at length about that accident. There was a lot of conspiracy theories around that accident, but let me be very clear. I've walked through that wreckage.
Hmm.
They reassembled that wreckage, and they reassembled it in New York, but then they sent it to a NTSB training center in Ashburn, Washington. And I've walked through that wreckage. I've talked to the metallurgist. There is no doubt that this was caused by a center fuel tank explosion. This airplane was in pretty heavy heat, 100-degree type heat, with no fuel in the center tank. They didn't need it. And so the fuel vapor in the tank reached a pretty high level. And the unexpected event was arcing in a wiring bundle that let high energy electricity get into the fuel quantity indicating system. That's a very low voltage system. But that arcing occurred, and that was the ignition source that ignited the vapors in the center fuel tank, which caused the explosion that blew that airplane apart. And I talked to the chief metallurgist face to face, and I asked him, I said, any doubt in your mind? And he said, walk over here and look with me. And we looked at the deformation around one of the stringers or support beams in that center fuel tank. And he said, look, there's pressure here. Here's the center of where the ignition point was. There's no doubt in my mind. And this is one of the best metallurgists I've ever met. And for him to be that definitive, the case was very, very, very strong. Um, I've read the reports. I've talked to some of the conspiracy theorists, and they just don't hold up. They just don't hold up. So the cause of TWA 800 was a center fuel tank explosion.
Now, was there any way that could have been prevented? I mean, looking back at it, and you broke it down excellently towards how that whole aircraft had got the explosion. But looking back at it, do you see any possibilities that that aircraft or that crash of TWA 800 could have been prevented?
Um, as a result of that investigation, airliners today will take air into their system and they process it to extract the nitrogen, which is about 73 or 4% of the content of our atmosphere. And they extract that nitrogen and then they pump it into these tanks so that the it reduces the oxygen level. It reduces their capability of an explosion occurring to a level that we haven't seen. These nitrogen enriched center tanks have this problem. So the airliners today are pumping nitrogen into tanks that are not full, just specifically to prevent another reoccurrence of a TWA 800. TWA 800 was actually not the first time that had occurred. There was a Philippine Airlines 737-400 that was taxiing out and had a center fuel tank explosion for the same reason. So the industry became aware of the problem and now, fortunately, has taken steps to avoid it for all the airplanes that we're flying on today.
And today, Captain Cox, most aircrafts or airlines they fly now with just a pilot or a captain and a co-pilot. Wasn't it a time there used to be a third person that used to be in the aircraft, but I believe it's just two people now, the captain
Right.
and co-pilot. Is that the case?
Yeah, in the early days of aviation, when you talk about the 40s and 50s, as the complexity of airplane systems increased, there was a need for somebody to operate those systems. And he became known as the flight engineer.
Mm-hmm.
And their sole job was to manage these very complex systems. As aviation evolved, automation was able to take that management function and decrease the workload to the point that that position could be eliminated. So the last aircraft with flight engineers were the wide body aircraft, the Lockheed L-1011 and the McDonnell Douglas DC-10 and the early versions of the Boeing 747. Those were about the last of that generation. Everything since then, uh, all the Airbus products, other than I think the early A300s, but all the Airbus products, two pilots. All the Boeing 737, the later 747s, all the 757s, 767s, the 777, the 787, they're all two pilots, and they use automation to help manage those systems so that the need for that flight engineer is no longer they're just no longer needed anymore.
Mm-hmm. Captain Cox, as we're wrapping up or running close to the end of this particular program, and first of all, you provided a very excellent presentation of facts, expertise, and just a tremendous gift of knowledge towards this particular subject. And I definitely really appreciate you being available. But what would be, let's say, today and moving forward, what would be the biggest concerns that you have towards the aviation industry, and what would be the biggest sense of satisfaction that you would have currently and moving forward towards the aviation industry?
I guess the satisfaction I've had, I've been in aviation almost half of its existence, which amazes me. But to see the transition and to see the focus on safety, on moving people around the world safely, and to a striving for continuous improvement, safety management systems, crew resource management. These are concepts that grew out of some of the accidents, but they've been embraced by the regulators, but also by the operators. So it's an industry-wide commitment to that ongoing safety. That has been probably the most rewarding. Accident investigation is very tough, and it's to be involved in a major accident. You go places that no human wants to go and see things that nobody should see, but you do it in an effort to make sure it doesn't happen again. And we're successful with that, and have been for decades. The areas of concern um, are the increasing demand for skilled individuals, pilots, mechanics, maintenance technicians, flight attendants, flight dispatchers. These are safety critical positions, and the demand is increasing. The number of airplanes we have, the number of passengers that want to fly, the amount of cargo that wants to be transported, all of these are increasing. And so, how do we meet the personnel requirements and not have an erosion in safety? We do it with training. That takes time, it takes money, and it takes commitment. It takes recruiting to get young men and women into our profession, and to help them learn the skills necessary to be the next generation of aviators, of maintenance technicians, of flight attendants, of flight dispatchers. All of those come together. And then the recognition of the how very capital intensive aviation is, and to get the support of the financial community to keep this vibrant industry alive and well. So there's a lot of challenges that we face ahead of us. We need to make the airplanes more efficient, but in so doing, we need to make them better, safer, and more efficient. You can't do one without the others. So I think those are the challenges that we face. And I have concern about how effective can we recruit the next generation, and the one after that, to keep the success of aviation going.
Captain John Cox, I can't think of a better way to end this particular I guess, interview or subject that we discussed this morning on Face to Face. As I ask the guests every single week, if there's any last words, any last things you would like to leave the audience, feel free to do so.
Um, I think I would close it with this. One, I've enjoyed the interview and thank you for the invitation. But two, all of us have a responsibility for aviation safety. When you sit down in that seat, you have a responsibility. You need to listen to the flight attendant briefing. Where's the closest exit and how do you operate it? And most importantly, when you're in your seat, have your seatbelt fastened. That is your contribution to aviation safety for yourself and others. And if we are to continue this unbelievable transition that we've made from December of 1903, when the Wright brothers first flew, to where we routinely travel around the world without a second thought, if we're to keep that momentum going, it's incumbent on all of us, pilots, maintenance technicians, flight attendants, dispatchers, aircraft management, the regulators, the investigative agencies, the manufacturers, and the passengers. And so we all have an obligation to do our part to keep this incredible industry alive and well.
Those words are well taken. Captain John Cox, it was my pleasure, our pleasure here at AccessTV.org network to have you as a very special guest this particular morning on the Face to Face talk show. And I wish you the very best of luck in many different projects or anything that you're working on. Didn't even have a chance to talk about your company, Safety Operations Systems LLC. Maybe we can save that for another time in the very near future. But again, it was our pleasure to have you on Face to Face, and thank you for this interview segment.
My pleasure. Thanks for the invitation.
You're welcome. Take care.
Okay.
Okay, this is Jonathan Small. Just enjoyed hosting this edition of Face to Face with the guests, President, CEO of Safety Operation Systems LLC, Captain John Cox. He provided an excellent presentation on the aviation industry and the areas that we were willing to discuss. And it seems like he has a book of knowledge beyond just what we discuss. And I highly recommend him for anybody looking for aviation analyst expert. Looking forward to being back here next week, if it's God's will, working on making a decision of an All About You or face-to-face talk show. But until you see me again, have a very blessed day and keep the faith. Thank you.